Well, I don't know about you. I hate morning classes, so good morning. My name is Valentin Viktorovich Voroshilov.
Sorry, Professor, I can't really hear you from here.
You can't hear me? Thank you. Please be proactive as that student. Better?
Yes, thank you.
Thank you. So this is my original name. I'm not going to make you say it. My current name is Valentin Voroshilov, but still, for some of you, might be too complicated. So I've changed it several times, and finally, I come up with a simple, easy to remember nickname. This is how I will be signing my emails to you from now on. This is how you should call me. All my students call me that. And I've taught a lot. So this is a reminder that having a WebAssign account is mandatory, and if you haven't done it yet, please find this page in the syllabus and follow the steps and keep listening to this introduction. As you can hear, English is not my native language. So I was born in Russia, grew up, got my education, and then moved to Boston. And I've been teaching lately mostly physics, but also algebra, geometry, trigonometry, problem solving, logic, methods for teaching physics, methods for teaching in general. And I taught to middle school students, high school students, college students, university students, middle school teachers, high school teachers, students with learning disabilities. So I've got some experience in the field, but that doesn't mean I know everything. That doesn't mean I don't make mistakes, because everybody makes mistakes. I may make a little bit less mistakes than some other faculty. Also, I have to inform you officially, I have no formal education in English. I learned it myself from books, tapes, but mostly from American radio and TV shows. So my vocabulary, pronunciation, and grammar sometimes might be way off. So good thing it's not a literature class, it's physics. So words don't really matter sometimes. Also, I have to force my throat muscles to work in a special way. So the way I sound has nothing to do to the meaning of my words. And this is first time I actually kind of speak English after the long break, you know. So it's going to take a couple of days to recover that ability. But, you know, it's not my problem, it's yours, right? So this is my standard disclaimer. Now, recently I had some events which limit my mobility temporarily, so I'm looking for a student who could help around with my equipment for my class and a couple of other classes. If you are interested, or if you know who someone might be interested, please just talk to me or send an email. That's in your own interest. Nowadays, you can find lots of information about everybody on the internet. We are all in Google, so you can check what other students told about me. This is a very typical student feedback from the past. Don't read it. Basically, what you see is for every positive opinion, there is exactly opposite. For every negative opinion, there is exactly opposite. I like these two, you know, especially. one student writes, you can tell he wants his students to understand and do well. And another one writes, never felt like he cared for his students. The question, natural question is, how could it happen? Two students spent same amount of time in the same room, watching same person, listening to same person, came up with completely opposite views, right? What do you think? Do you think? Think. I'm not asking what is the answer to this question. Maybe it doesn't exist. Yeah. What do you think might be the answer? That's slightly different. Yes, what do you think? Probably, but I doubt. What do you think? Anybody? What could be the...
They got some pretty great.
Maybe. I don't know. That's impossible to figure out because all reviews are anonymous. There is no correlation between the name and the review. Yeah? Pre-med students, what do you think? Yes? Well, why would one person ask and another person didn't ask? Well, if you want to ask and you don't ask, well, if you have a question and you don't ask a question, something prevents you from doing that. So one person asks a question and another person in a similar situation doesn't ask. So why? Well, there is no right or wrong answer to this question, but again, from my personal experience, it's based on basically attitudes. It's a well-established fact now that different people learned differently. Yeah. It's happening here, and psychologists had studied how people learn. There is no one path for learning. There are many different paths, styles, and different teachers teach differently. And sometimes learning style of a student may not match teaching style of a teacher. And in that case, of course, there is some frustration. And frustration always leads to, well, some negative output. So some of you will feel that frustration. What you going to do? So you feel it's not working. Well, the good thing, this is a physics course, right? Not a Catholic marriage. You can divorce. But if you do that, it's on you. Yeah. Should you stay or should you go? I don't know. I can't go. It's my course. I have to stay. So you have to make your decision. Of course, I hope no one would leave and everybody would stay and everybody would get an A in the end and gave me only positive reviews, but I know it's never going to happen. So I just think positive. Some people believe our universe is just one of many, and maybe there is a copy of you taking a copy of this course in a copy of this universe from a copy of me. So I happen to believe if that happens, you getting the highest grade from all of you. Thinking positive is important. We should believe that what we do here now is good for us. Yeah. Constantly doubt themselves doesn't help. People who do that just don't succeed, and you want to succeed. So be positive. And this is another reminder that soon I'm going to ask you a question. And so where I am here. First, I want to see what's happening with the web sign. That's on my side. No one was late. Interesting. 31 students answered the question number 1 out of how many? 70? 80? Well, see, I didn't ask the question number 2 yet, but you already answered. Why? Don't do that. See, the instructions, when you log in and you click on the lecture questions, the instructions tell you, don't answer questions until they asked, right? So follow the instructions. All right. So if you already have answered question number 2, well, just take your time. Everybody else, please tell me what you think. Yes? Well, at this point, all I can say is try to follow the steps laid out in the syllabus. If it works, perfect. If it doesn't work, in that case, probably at some point we should sit down and see, yeah, this one. What prevents you from doing that? You're using student account. I use a different type of account. I cannot see what you see. I don't know what problems you may have. I have no problems. Yes? So most probably you're logged in a different course. I don't know. Well, that clearly is the first mistake I just made. Well, not just now, probably I missed a version of this assignment. So that only means that 12 people who already answered even more wrong so you should follow the responses on the screen. Just ignore the words, just use numbers. That's it. So you may have taken physics before or not. It doesn't matter. You still may have a feeling how good you may be in this course. That's a feeling. And depending on your feeling, you can answer, you know what, I've got plenty of extra spaces, so this is what I want to do. Because 2 has been already used up. Let's make it 3. It's completely open for you. All you have to choose is a number. That's it. So if you feel that you may be very good, your number is 9, and from 9 down to 1, Your feeling describes, basically your uncertainty. And by the end of this class, I will not be able to figure out who said what. All I see is just a distribution. I'm only interested in the distribution. I don't really need to know who answered 9 or 7 or 5, because by the end of this course, I'm interested if the distribution would be different or not. So please keep answering. By now, you already know your answer. It's in your brain. And what I want to say is, from my experience, your feeling probably in reality is not correlated to your final grade at all. There are much more important things which affect your grade. Number one is your background. Learning physics or learning anything else goes in stages. And every new stage is based on the previous information, on the previous skills acquired. And sometimes your background might have some holes, but good things, this is elementary physics course. It requires elementary background, and if something is missing, it very easy can be recovered. But it should be recovered. And theoretically, everyone can get an A because the finish line is the same for everybody. But depending on your background, your starting point might be different. So kind of distance traveled from the start to finish might be different. The amount of effort for different students might be different, but the final goal is reachable for everybody. Boston University is one of the top universities in the country, in the world. So physics faculty at BU, they have certain expectations about BU students. And the number one expectation is the attitude. Never give up. If you don't know this fairy tale, look it up. Be active. Be proactive. Proactive, plan ahead. To plan ahead, you have all the information. The syllabus tells you every single part of a material which will be learned, when, how. So your final grade basically is based on your, not even social, but working skills. How good you are at making you propel, ahead. This is a copy from the syllabus, so just to prove that you have it. You can see. And if you can see, you can predict. And if you can predict, you can plan. This is a very standard course. It has a very standard structure. We have lectures, we have homework, we have exams, we have labs, and we have discussions. But in this course, labs and discussions put together in one single unit. We call it investigative laboratories. Well, first, it makes it longer. So lab plus discussion time. And of course, some students don't like that, but some students like the fact that they don't have to drive twice for the lab and for discussion, so there are always pluses and minuses. The word investigative means that fairly often in a lab, you will be discovering material before we will be talking about that material here in a lecture. That's what science is about. You feel frustrated. That's what science is about. So teaching fellows will be helping you, and every section except the section number 6 will have 2 teaching fellows. So you will have to communicate with them, be active again. The material is aimed, adjusted at an average student. So some of you may feel like it's very easy, feel boring. Still pay attention because you may miss some important hints or advices. But on the other hand, some of you may feel that material is challenging. In that case, you should be active. You should have a notebook, and if you have any question, something confuses you, you should write it down. And then after the lecture, as soon as possible, you should unconfuse you. Go to office hours, send an email, ask a question. So everything's supposed to be as clear as possible, as soon as possible. And listening is not working. It's not participating. Participating meaning doing work. Well, right now, of course, there is no work offered to you to do. But in the future, when we're going to do problem-solving exercises, you should do as much as possible to follow all the steps on your own. Because every action you make, drawing, saying, just looking around, activates extra neurons in your brain, and that helps to build up more connections, and learning is basically building connections. That's it. So officially, today is the first day of the labs, but the lab number 1, as you know, has been available for everybody who has the access to WebAssign. Today, you can finish it. For the WebAssign, you can use any device. You can use a laptop, you can use tablet, you can use a phone. WebAssign works on everything. So it's up to you. Something big and heavy with a large screen, or something smaller with a smaller screen, doesn't matter. Plus today, from 10 to 6, you can go to one of 2 lab rooms available for you. Just go in, pick up a computer. If you need a computer, sit down, and do it. That's it. Tomorrow, we start a practical lab, and all lab take places in specific rooms. If you leave this auditorium through this door, this is what you're going to see. On your right, there is a room 121. All office hours take place in that room, all of them. And then from right to left, lab rooms 128, through the glass door 130, on the left 134, 136. Today, rooms 134 and the 136 will be available for you if you need it.
Sorry, Professor. For those who have signed up for Monday and Wednesday lab timings, that means that we have finished the lab assignments for lab 1 by tomorrow.
Lab 1 is a special lab, and you have to finish it today by 10 p.m. It's online. It doesn't require any equipment except computer and internet access. So if you have it, you can do it anywhere. If you don't have it, in that case, you should go in one of these 2 rooms, 134 or 136, pick up a computer and do it there at any time during the day. Now, many labs are computer-based, so you will be using equipment attached to computers. Please don't use these computers for anything lab unrelated. And the rule number 1, be safe. The rule number 2, keep it clean, please. It's a standard ethic rule, at work. When you leave the room, make sure it's in the same condition it was when you entered that room. So right now, it's pristine. So if you follow that rule, it will pristine after all the lab sections go through this room. That's it. Now, the syllabus BU policy gives you some flexibility. You can use that flexibility. Just keep it in mind. Everything is reflected in the final grade. Yeah. I've been teaching this course for 11 years, probably about 300 students, no, 3,000 students. 2 students didn't pass the course because they didn't have 50% of the homework done. I don't know why, but that happened. Homework is online, and in the last year, I set different deadlines for different parts of the homework. This time, I decided that all homework parts, which already should be available, you can see all 4, homework 1, part 1, homework 1, part 2, etc., etc. They all should be available on the website, and they all have now exactly the same deadline, the last day before the first exam. So on one hand, it gives you some flexibility. On another hand, it's a trap. You may feel, well, so much time ahead. I'll do it later. No, you won't. It's physically impossible to do all homework in one sitting. Trust me, people tried. And that's why I recommend just follow these recommended deadlines. On average, you should do 3-4 problems every day. Ideally, as many as you already can, based on the material. That's it. So waiting until the deadline definitely means losing some points on the homework. And whoever will send me an email in 2 weeks, Mr. V, I've been so busy, could you please extend my homework deadline? No. You've been warned. That's why I'm doing that. I'm warning you. Well, solving a problem in physics requires a certain strategy, which is absolutely the same for anybody who is solving that problem. Anybody, because the strategy doesn't depend on personalities. It depends on physics, and physics hasn't changed for hundreds of years. So you need to be able to read it, imagine what's happening, describe in your own words, etc., etc. And every single step also has a structure, and that structure can be described in questions which you can ask to yourself when you're not sure what to do. So this is just a copy from the syllabus. I advise every time just have this page with you. When you do a homework problem, not sure what to do, just start asking and answering these questions, one after another, after another, after another, until you get some insight on what might help you to propel. WebAssign requires certain accuracy, and your answer is supposed to be within 4% margin from the actual answer. But normally, it's not a problem. If you keep 4 digits after the decimal point, normally that automatically gives you the right accuracy. We don't care in this course about significant figures and error propagation, because this is not a science course. This is a practical course. skill building course, you know. So we need to know and be able to solve problems. And many issues around it, not important. For each part of each problem, you have 6 submissions. But sometimes it's not enough here. So the rule of thumb is, if you tried it 4 times, it didn't work, stop trying. Go to office hours. This is an example when a student lost 2 submissions for nothing. For example, well, first of all, if this didn't work, that student should have stopped and go to office hours. Another thing is, if that student would tried this 3rd submission with 4 digits and it didn't work, that's it. This number just was just wrong. Plus, 4% of 277. Yeah? How much is that? Well, we don't need to know the exact number. 277 close to 300. 1% of 300 is 3. 3 times 4, 12. 277 is a little bit less. So 10 is a good estimation. So if this number is wrong, that means this number is at least 10 points away from the correct answer. So trying to adding extra digits, not going to help. So these 2 submissions just lost for nothing. We have plenty of office hours, the actual office hours on Blackboard, so use it. My office hours, I don't remember. I don't have to. I have people who remind me. So, plus teaching fellows have their own office hours. And in the end, labs, discussions, homework, and exams together lead to your final grade. Yeah? Final grade, of course, is a number between technically 0 and 100. And after that, that number has to be converted into a letter grade, right? So a number is an entity of a number line. Letters just like boxes. So to make a transition, the boundary between different letter grades should be drawn between A and N minus, one boundary and another and another. And when the boundary is drawn, there's always someone close to it. That's inevitable. Like this student wrote, I'm 0.3 points away from 90. Yes. And that's just a fact. Maybe someone even closer. So what? The rule about boundaries, they must be robust. They must be stable to small possible fluctuations in any calculations or errors. So the boundary is not an arbitrary line. No. The boundary between letter grades must have a big gap. So you see, small gap, small gap, small gap, big, small, small, small. The big gap in this region automatically tells where the boundary has to be drawn, has to be. It's not a choice. And because of that, the boundary depends on actual distribution. And because actual distribution depends on, well, people, different years, different people, different courses, different distribution, slightly different boundaries. This is one of the examples. You see 96, 90, etc., etc. Student writes me, would you please round my grade to 95? No. If I round the grade for one student, I would have to round the grade for everybody. If I do that, the whole meaning of gaps disappears. No way to figure out the robust boundary. So All decimals matter. There is no rounding up. Another example from a different year. Another example. So I have 74.4. I want 74.5. Is there anything I can do? No. See, this equation has 6 terms, right? Lectures, labs, homework, exam, exam, exam. That's it. So there is nothing else which can be done to change the final number. I feel, well, in physics course, that's just the wrong word to use. Physics is based on facts, not feelings. But I feel that I'm close. I put a clear effort. Well, again, first of all, lectures, labs, homework, exam, exam, exam. There's no term which says effort. Maybe it should be, but it's not up to me. There are people above me who decide policy, and they don't write the manual which says how to assess different amount of effort and convert it into the final grade. So without that, that's only lectures, labs, homework, exam, exam, exam. But of course, your effort is implicitly in each of those numbers, inside them, hidden. So there is the relationship absolutely between the effort and the final grade. Taking a course in a way is like running a race. Decimals matter. Without those decimals, there is no way to see the distribution. And grading is basically like automatic procedure. A robot could do that if you have that algorithm just programmed. Any questions, please? Now, if you have a question in this course, you have two options. You can wait until I ask any questions, or you can raise a hand and ask a question. What you gonna do? It's up to you. Now, the best strategy to get the highest grade possible is just not losing any points. Lectures, labs, and homework, that's free money. Yeah. All you have to do, just do. Yes?
Is there a way to check that the web assignments work correctly? Like, or the syllabus is the way you enter the wrong, you might not get points.
I will be checking that today. So I will see who has some issues, and I will reach out to those people directly. It's not, I don't know why. I think it's a very simple problem. I don't know why it's not done automatically. I don't know why every year we have to spend time and effort to figure out for a dozen students what doesn't work and fix it. But, well, it is what it is. So, putting effort in lectures, labs, and homework is important not because of just a grade. It is important because it helps you to get the best preparation for the exams. The exam problems have similarities to problems solved before the exams. Where? Well, anywhere. Could have been here, could have been in the lab, could have been at home, maybe some parts of those combined together. But there are no surprises. And if you open the exam and you read the problem and you feel surprised, well, you missed something. Lecture, lab, homework, I don't know, but you did. And the best way to get prepared is, first of all, if you have any confusion, don't wait a week, because it fades away. You forget that you had a question, and that question might become important. It might be too late. So if you have any confusion, try to unconfuse yourself as quick as possible. Office hours, Piazza, friends, a textbook, Wikipedia. Nowadays, any textbook is as good as any other textbook, because, again, at least elementary physics hasn't changed for hundreds of years. So it doesn't really matter what book you want to use. You don't want to use OpenStack's book. You can use any book. Actually, old books sometimes better than new books. More clarity. So if you work at home, maybe you can chat, communicate with someone live, because it's always like gives some synergy. Communication brings some synergy in thinking process. The best way would have been just having a study group, work together. Yeah. Well, but you all have different circumstances. So just try to fix everything as soon as possible. Fix means understand every step of every action which you or your fellow student uses to solve a problem, to get from the beginning to the very end. Every solution has steps, every step has a reason, and understanding those reasons is much more important than just solving the problem. Well, you'll see. We have 6 weeks for that. Now it's a question number 4. And that question also will be anonymous only distribution. What do you think about physics now? Not about you in physics, about physics. How would you finish this sentence? What single word would you choose? So please make your mind, pick a number, because I'm going to switch to a different screen to see the progress. Well, you know how it works. If you would choose strange, you enter 1. Yeah. Done, 2, simple, 3, boring, 4, etc., etc. So you read all answers, you pick yours, you remember the number, and you don't need the slide anymore, right? Lectures is being captured by BU system, but sometimes, by some reason, the quality of video or sound is not very good, some fluctuations. So as a backup, I also tape it. If anything goes wrong, at least I have some backup. And it will be available on Blackboard with the slides. So there's plenty of information for you to reuse after each lecture. All right, so what do we have here? Question number 4. Well, first of all, the question number 3, which actually question number 2. Yeah. The majority says 5, which is a safe choice, I agree. Yeah. Now, here we have 2 winners, 7 and 8. Seven, mysterious. Don't try to flatter, it's not going to help. 8, hard. That's a very common answer. Yeah, I expected that would draw some responses. Well, let's talk about it a little bit. First, many people think that in order to succeed in physics, one has to be good at mathematics. That's a myth. I know many people who are very good mathematicians, very bad at physics. And if you remember middle school, high school, the hardest part of math for many is solving word problems. In physics, we call them problems. That's it. So a problem-solving skill has nothing to do to mathematics. Plus, for elementary physics course, only elementary mathematics is needed. And if you even might forget some part of that, it's very easy to get recovered. Second statement, physics is hard. That's not a myth. That's a lie. Invented by people who are not really good at physics, that's it, as an excuse. Physics is not hard. There are much more harder things in life. For many people, for example, learning how to balance on a rope is much harder than to learn a problem about how to balance on a rope. And we will solve a problem about how to balance on a rope. And you will learn how to do that. But I doubt you will be able to learn how to balance on that rope. So keep it in perspective. In a way, there is some similarity between learning physics and juggling. Well, any healthy person can do this. Anybody who's healthy can do this. And any healthy person, well, can do this. Oops. Even not so healthy. 3. No. Going from 2 balls to 3 balls requires a steep jump in amount of practicing. It's not a matter of anything else. It's a matter of practicing. But lucky you, this is a 2-ball course. It's not a 3-ball course. So anybody with a certain amount of effort succeeds. Again, mathematics is not the most important part. Plus, when you do the lab 1, if you do it right, it says don't spend too much time on each question. If you do it right, it will tell you some parts of mathematics which you find confusing. In the future, every calculation from that math test will be used in this class at some point. So if you very good, if you have solved it, no problems, well, you absolutely ready math-wise. If something like throw you off, well, in that case, go to office hours or read a textbook. But you know what you need to refresh, what knowledge or skill from mathematics needs to be refreshed beforehand because it will be used. But more important part is imagination. Physics is based on experiments, and it's just physically impossible to do all physical experiments. We have no time, we have no equipment, so we will have to replace actual experiments with mental experiments. We have to be able to manipulate with mental objects in our mind. That requires imagination. It's much more important than mathematics. And of course, when we learn, we make mistakes. It's natural. So we make mistake, we try again, we make mistake, we try again. And having friends, helpful. You don't have to be able to solve all your homework problems completely on your own. No, you do it together. But again, you need to know the meaning, the reason for every step. That's it. So we are somewhere here with chemistry, biology, yeah. And of course, It's based on our ability to read, to write, to count, etc. But also some other professions, type of thinking based on the type of thinking developed in physics. So that's why physics, nowadays at least, is much more than just a knowledge about nature. No. In the physics course, people develop skills which nowadays very important for any profession. Physics is a science. And in science, of course, we start from looking around and seeing things which excite us. And when we do that, well, we call it observation. If we see objects, something happening to those objects, we call them processes. Those objects, processes, have properties. We need to describe those properties. And, well, we turn to our fellow scientists and say, hey, Jim, see that thing? No, not that thing, that thing. No, not that thing, another thing with a thing, we do that thing. Well, eventually it might work. But if you try to write a paper, yesterday I was experimenting on a thing which was doing that thing, no one's going to publish it, right? That's why every science has invented and developed its own language. And study science is very similar to study foreign language. It requires a lot of just memorization. It requires a lot of kind of translation. And by the end of this course, this is what you will learn. Again, that's a part of a syllabus. So you don't have to read this slide. If you think it might be a lot, well, you may reconsider your professional path, because this is nothing, tiny portion of what med students need to memorize. There are some internal, again, crucial similarities between learning physics and learning anything else. So if you succeed in this course, you succeed anywhere else. Well, all right. Let's spend a couple of minutes on this discussion. Science. Well, people do things because they love doing those things. But as a humanity in general, why do we need science? What is the mission of this human practice? What do you think? And when I say, what do you think, it might be you. What do you think? So does it mean that if we need to solve a problem, we must use science? No. All right, so it's not the exact match, but very good. So anybody else? Please tell me, what do you think is the mission? You don't have to look at me, right? As long as you can hear me, that's it. Screen, sound, that's all you need. What would be so, I don't know, bad or wrong, awful without science in our lives? Anyone? Yes? What is the connection between science and this chair?
Science. Processes and materials.
And people who have been creating those materials, those people, what did they use from science per se? All right. So many words, I got lost already. But there was one word which was much more important than others. There is always, in every text, in every problem, in every explanation, there are words which are much more important than other words. And we need to learn how to figure out those words. That word was future. Science deals with future. Magic also deals with future, but in a different way. What's the difference between how science deals with future and how magic deals with future? Yes? Well, if we put these three together, the answers together, we kind of get the picture. We need the explanation. We use it to make our future better. But in order to make our future better, we need to make sure it will be better. So we have to make a plausible prediction. And that's what science is about, making prediction. Everything else grows from that, because if I can predict that material will be sufficient, softness, size, I can test that prediction, of course. But without ability to make those predictions, everything goes to just beliefs, pure magic. Why did it happen? I don't know, it happened. So the mission of a science as a human practice is to make people be able to predict what might happen to them in the future. But prediction also is based on something people observe every day. For example, there's something which everybody observes every day, every single day. And many things, but one of those things is the sun. Comes, it goes, comes, it goes. And we can predict in the morning when it goes out that it will be the time when it goes down and then up and down again. So we start from searching for those processes which allow us to make those predictions. Those processes have names, patterns. So scientists searching for patterns to use them to make predictions. That's it. That's what science does. And of course, for that, we need to, well, collect some data, do some measurements. And in the end, we have to use some equations to analyze those data. That's when mathematics comes to play. But again, if you go through all the steps, mathematics is the last thing which comes. The last. Before that, many more important things should happen. Observation, pattern recognition, pattern description, etc., etc. And no data, no patterns, no ability to make predictions. That means it's not a science. Physics is a science. Education is not a science. It's a scientific field. There are people in that field who do scientific research. But at this point, education is just like alchemy. So maybe in the future, it will become a solid science, but so far, it's not. Patterns are everywhere. There are many different types of patterns. Visual patterns, numerical patterns. Where's my mouse? Oops. Okay. Let's see. I'm not sure. Well, I could hear it. That's sufficient for me. Let's see if I can increase. This is an audio pattern. Come on. Anyway, oops. In physics, all patterns based on statements, two types of statements. One we call definitions, one we call laws. And the difference between these is a definition is something which has been offered and agreed upon by people to describe something. It's a result of consensus building process. It depends on us, humans. A law doesn't depend on us. A law is an entity of nature. And so this week we're going to talk about kinematics. Next week we're going to talk about forces, etc., etc. This is what we're going to learn by the end of 2 weeks. Again, don't read it. And first, what we need to say about physical study, it begins from measurements. When we describe the world using words, we have to make a bridge from verbal description to mathematical description. We have to be able to assign a number. Without those numbers, we cannot make reliable predictions. Reliable predictions usually based on equations. And a definition of measurement, which you can find in any standard book on metrology, is not very specific. In physics, we make it more specific. It's not just the goal we need to assign a number. It's also a procedure. How? So in physics, if we want to measure something, first we have to select a standard of that property. Then we have to establish a procedure how can we compare the similar property in a different object with the property of the standard. And in mechanics, we have 3 basic standards. Number 1 is the standard of mass. So about 70 years ago, people convened in Paris and selected a standard. Selected a standard of mass. So they made a cylinder, pointed finger at it and said, let's call it 1 kilogram, not just something, 1 kilogram. Agree? 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 Agree. That's it. That's how that standard has been established. Now we need to figure out how many kilograms in something else. To do that, we have to be able to compare that property we call heaviness or mass. And how can we compare? Well, we can do it this way. No, not 1. All right. Yeah, that's 1. Feels exactly the same. Did I compare? Yes, I did. Well, now I can take a look at it. Okay, these 2 together make 1. Now I know mathematics. That means one of these will be a half of it. And I call it a half. Of course, I can divide it into smaller parts. But first thing to do, I have to eliminate a person. Not because I don't like that person. No, I like almost everybody. But because people not very accurate measuring devices. So people have invented other devices which can be used to compare this property, like double pen balances. No, not enough. All right. Same height, same property, same amount of that property, same mass. But nowadays, of course, we have many different ways to measure this property. We could use a spring scale. A spring scale is a calibrated device. What did we do? Well, we used the etalon, a standard, a prototype, and well, this is not kilograms, those are newtons. But still, we draw a mark and write a number, any number technically. Doesn't have to be one. And then we divide it in smaller parts. Well, here probably is better. 1. So I have another one. 2, draw a mark, right. 2, divide into tenths or hundredths or thousandths and give the name to each part. Yeah. Grams, milligrams, centigrams. But the most accurate device to measure mass, of course, is electronic scale. We can use it. And in the lab, you may be using different types of scales. It depends on what we have available at the time. When you need to measure mass, all you have to do is use a scale. Don't do this. Not accurate. The next important mechanical standard is distance. So whenever we need to measure a length of something, we have to compare with the etalon, with the standard, with the prototype of length. Again, initially it was a portion of a meridian, then it was a specifically chosen, prepared rod made of alloy. And now we just have these sticks. And we call it a meter. And if I want to count how many meters can I fit in something, all I have to do is this, right? And actually physically count. 2, 3. That's it. And of course, I can do the same thing, division. I can divide it in tenths, call each a decimeter. I can divide it in hundredths, call it a centimeter. In thousandths, call it a millimeter. And now I can measure the length of anything. I just have to read the number. And the third standard in mechanics is time, standard of time. This is a little bit trickier one because it has to measure the length of a certain process. But to measure the length of the process, that process has to repeat itself. And to do that, we need a process which we call a periodic. It has a period, like this one. And now we can say the time it takes for this ball to go back to initial position. Let's call it 1 Mississippi. Let's call it 1. And then we can count how many the same periods is fit in the longer intervals. Yeah. 1, 2, 3 seconds. Yeah. But naturally, we have more advanced devices to measure time. Kitchen timer. What is based on? Well, It's based on the fact that springs also might provide periodic motion with a fixed period. Or we can use electronic devices right now. So these three standards, mass, length, time, they form the basic units of measurements in mechanics. And all other physical variables which also have units can be measured in terms of these three standards. These three standards, kilogram, meter, second, they belong to so-called International System of Units, or shortly SI. So when you solve a problem, most commonly you can use any units, but nowadays the most commonly used system is international system in the classes. Well, of course, as you know very well, you know what? Done. There are many different units to measure same properties. To measure length, we can use yards, feet, inches, miles. To measure time, we can use seconds, minutes, hours, years, light years for distance. And for each combination of units, we always can recalculate one unit into another. These type of calculations called factors, conversion factors. And we call this procedure a conversion. And this is just one of the many possible conversion factors here. And the most important factors will be always available to you on the exam. You don't have to memorize all of them, although it would be helpful. And if you solve a problem at home and you're not sure what to do, just Google it. This is an example how it works when we need to make a conversion. So here in this problem, we need to convert 54 miles per an hour into meters per second. Well, that requires two actions. And that requires converting miles into meters and hours into seconds. And that requires the search for two conversion factors, one which relates miles and meters. And search means literally searching, not this, not this, not this. Miles and meters, done, found. The first search is over. And this conversion factor will be used in the numerator. Now, hours and seconds, not this, not this. Okay, second one. Now we actually use them. So 54. We don't touch this number. Now every unit, and a unit is that combination of letters which represents what standard is used to get that number. Every unit has an invisible one, like in algebra. Yeah? 1 mile over 1 hour. But now we can start using these factors, and using literally means substituting, plugging in, replacing. So 1 mile, this is supposed to be replaced with a number equivalent in meters. 1 hour supposed to be replaced with a number in seconds. What do we do now? That's what you do now. I'll do it. You could have already solved it before, you know, instead of just waiting for me. I've been giving you time. So what do you do? Well, first of all, if you, that's an advice, that's not a rule, that's an advice. If you look at your calculation and you see you can make it simpler, make it simpler. For example, at least like this. You can make it even more simpler here because the common factors, 16 is 4 times 4, 36 is 9 times 6. I'm just waiting for you. Someone should tell me the answer. This is the, so the last answer is what we've been looking for. It will be the same speed, but measured differently in meters per second. We need to get this down. Yes? I don't know. What's your answer? Well, 36. 4. 24. That's why I hate morning classes. My brain is not at its peak. So this is a very trivial example, of course, very simple. However, it represents the general strategy, and all examples which I'm going to be offering you here are simple, because all examples to demonstrate the use of the strategy, not to solve a specific problem. When we get the sense how the strategy works, that's it. It can be applied to any problem. So please, tell me, what do you think is missing in that sentence? Anybody? Yes? A unit? We don't know, is it miles, kilometers? So a sentence like that is just wrong. Yeah? So we have to clarify, we go online or wherever. So in this situation, turns out those are millimeters. But millimeters, of course, is a very inconvenient unit. We have no intuition on that. So we want to convert it into something better. And to do that, you can do conversion. And there are many types of conversion. And in this particular example, the same length, exactly the same length, can be measured in inches, miles, feet, millimeters. For us, sometimes it doesn't really matter what specific unit is used. What matters is it a unit of length, or is it a unit of mass, or is it a unit of time? Units which used to measure the same property form a dimension. That's a name for all those units together. And in mechanics, we have 3 dimensions: dimension of length, time, and mass. Dimensional analysis tells us sometimes when an equation which we want to use is wrong. It can't tell us if the equation is definitely right, but it definitely eliminates wrong equations. Because in physics, for any equation, for every equation. The dimension on the left and the dimension on the right should be the same. The unit on the left and the unit on the right should be the same. If that is not the case, it's just wrong. This is an example of a dimensional analysis. But I don't usually use those brackets. Those brackets represent the word dimension. So we would read dimension of 2 times dimension of A is equal to dimension of B times dimension of 4. It's just too much work, especially for me. So when I need to solve a specific problem, I just use actual units usually. In this situation, well, we can use dimensions, but we can use actual units. This is a definition of kinetic energy. We're going to talk about it later. Right now, I know that to measure mass, I need to use kilograms. To measure speed, I need to use meters per second. And according to this equation, I have to square it, square speed. And to measure 2, what do I use? Nothing. Numbers, coefficients have no units, have no dimensions, so nothing. Well, we can't leave it empty. We have to write something, right? So this is the dimension, the unit of a number. The unit, the dimension of a number doesn't exist. That's what it means. It's a multiple. So this will be the unit of kinetic energy if we use international system of units. Of course, we can simplify this because every unit, every dimension can be treated as a regular variable in algebra. So very simple algebra. We could have done it using general labels for the dimension of kinetic energy, the dimension of mass, the dimension of speed squared over the dimension of a coefficient. Now that should be, this is a variable which represents any unit of mass, length over time. These variables represent any unit of length and time squared, and a 2 has no dimension. The difference between this and that, this expression belongs to international system of units. This for any. It could have been grams times yards squared divided by, I don't know, years squared. Still would be the correct unit. Weird, but correct. I'm not going to ask you this question. So let's just go through this. Our goal is to figure out if this equation technically possible or it's just plain wrong. Yeah. So on the left-hand side of this equation, we have a variable which represents certain distance, and well, it's up to us. We can use general labels for the dimension of the distance, or we can use specific units like meters. So SI units. SI units or general. It is up to us. I choose SI. So on the left, we should have meters. What do we have on the right? Well, 1/2, it's a coefficient. It has no unit, so factor of 1. V, speed. Speed has a unit. Distance over time, or in international system of units, a meter over a second. T represents time. As a unit, if we use international systems of units, that's supposed to be seconds. But it has to be squared as a variable itself. So on the right, what do? Nothing, we just keep it. On the left, we simplify this using our algebra skills. So what's left? This. On the left, on the right. The answer is no, they don't match. As long as the units don't match, the equation just cannot be correct. That's it. Sometimes it's very handy to eliminate wrong things before starting looking for the right things. Any questions? This is just basic so far. So, no. This is actually question number 5, and this question I want to ask you. Please tell me, you have 2 minutes. So, question number 5, that should be available for you. 1 liter. That's how it looks like. It's about a box of, it's a box about this size, 10 centimeters by 10 centimeters by 10 centimeters. That's what 1 liter is. Of course, we can convert it into other units of volume. And here you have a list to choose from. If you make a conversion into international system of units, what would be your answer? What would be your choice? Please enter. By now, probably you already know what number you want to use as you. That's my alarm. It means I have 1 minute left. Yeah, 9:59. Come on. So, did you enter? Thank you. Tomorrow, I will reveal the right answer. I'll keep you in suspense. Any questions, just find me. Today I'm going to be around for a long time. Homework is on a web sign. You have to create an account on a web sign, and if you did it right, that should be available for you. Let me just check. I can check it right now. Can't hear you.
For lab, we go there 11.
Which first? For the first lab? For this lab? For this lab, you can do it anywhere during the day. You can go in a lab room and pick any computer, or if you have your computer, you can do it on your computer. You just need the app.